Hey guys, it's Dr. McGrath talking more about chemistry. So we're going to talk about what an atom actually looks like. So we talked about on the previous video the subatomic particles and their properties. So I want you in your mind to kind of think about what I had talked about before, and I said the protons and the neutrons were in the nucleus of the atom, and then the electrons were like in a three-dimensional kind of space outside. So if we think of all the protons and neutrons in the nucleus of the atom, you can think of the nucleus of the atom as like a little like dinner pea, like a green pea that you would eat at dinner, right? They're all in there in that little teeny dinner pea, okay? And then we're gonna think about the electrons. Remember the electrons, we said their weight is negligible and they're like in a three-dimensional space outside the nucleus. So if we think of the nucleus of the atom as like a little dinner pea, then think of the first orbital. An orbital is just the three-dimensional space outside the nucleus. Think of the first orbital as the size of like a ping pong ball. The P is in the middle of that ping pong ball, and then there's the ping pong ball around the outside. So the electrons zip around the nucleus in the three-dimensional space that the ping pong ball is, all right? So the first orbital, where those electrons can fit, only two of them can fit in that first orbital because they're minus signs, electrons. And if you bring two minus signs too close together, they'll repel from each other, right? So in that three-dimensional space, there's only enough room for two electrons. The next orbital, the next three-dimensional space outside, so we have a P, a ping pong ball, think of it like a tennis ball, right? That's a little bit bigger. So in that three-dimensional space holds electrons and they're zipping around out there, but it's bigger. So that one can hold 8 electrons. If another electron tries to come in, that's too many minus signs in that three-dimensional space and it will get pushed out to the next orbital. The next orbital, let's think of it as like a dodgeball, like a big bouncy ball that you used to play with on the playground. That orbital is considered full with 8, but can hold up to 18 electrons. And we'll get to what that means in a little bit. And any other orbitals after that, there obviously are many more. We don't care about them because they're really not in molecules or atoms that we care about in biology. You will in chemistry, okay? So how we like to think about this, there is a drawing that you'll see come up and it's called a Bohr model. And a Bohr model is just kind of a visual representation of what these atoms look like. So remember we dealt with carbon-12 before, right? It was carbon and it had an atomic mass of 12. So we did our little math equation earlier. So if it's carbon 12 and it's not going to be charged, so we know the protons is 6, plus we don't know the neutrons, and we know that the mass is 12. So then we know that the protons is 6 and the neutrons is 6, right? So how we would draw a Bohr model of carbon in this case is we would put, now you could draw 6 protons, like 6 little ball things if you want, and then 6 little neutrons, but I just put 6p and 6n. And that's in the nucleus of the atom, right? And remember, we have to draw the electrons too. And we said this wasn't charged. So P minus E equals charge. We know that this is 6. We don't know what the electrons are, but we know the charge is nothing. So then we look at that math, we figure out, oh, that's pretty easy. So it's going to be 6 minus 6 equals 0. So there are 6 electrons in an uncharged carbon molecule. So this is our first orbital here. So remember, we have to put the electrons on the orbitals. The first orbital can only hold 2. So I'm just going to put those little electrons on here. Okay, I just drew little E's, all right? Now, when you go into a chemistry class, they may have you put the electrons right next to each other because that's how they're drawn a lot. But honestly, for this class, the nomenclature of where you put your electrons on the orbitals in a Bohr model is not a big deal. So then we'll draw our next one. So remember we said that there were 6 electrons. Since we've already drawn 2, the next orbital has 4 electrons in it. So I'm going to draw those guys. 1, 2, 3, 4. And that would be the Bohr model of carbon. So remember, if we can think about what these models look like and where the placement of the electrons are, it's going to help us determine what this atom is going to act like. And by act, I mean bond or not bond with other atoms. So our outer orbital here has 4 electrons in it. So for that electron orbital to be full, it would need 4 more electrons. Okay, so this atom can make bonds. I'm sure you guys have heard before of things like called noble gases, and they don't react and they don't make bonds. The reason that noble gases don't react and don't make bonds is because their outer electron orbital is full. If the outer electron orbital is full, that atom's like, I don't want to interact with anybody. I'm perfectly happy. They really like having their outer electron orbital full. So we're going to talk a little bit about bonding next time and how we can tell what happens with this. Bye.